Good morning, everybody, and welcome on what's probably the warmest day. Thank you for tuning in. So my name's Gary Vizard. I'm the managing director of Energy Ace. We're a business in Lancashire, in Buckshaw, and really what I want to do today is just to give you a flavour of Energy Ace and two of the technologies that we manufacture. Next slide, please, Chris. So, Energy Ace, we're incorporated in 2002. We've got about sort of 2,000 customers. Have won a number of awards, 4 national awards and 1 regional award. And we provide solutions to about 48 different countries. Our main market is the UK. And over in Ireland as well, but we're certainly flying the flag for export. Next slide, please, Chris. We're quite strong on CSR. We support 2 main charities. One is National Energy Action, which is all about fuel poverty and trying to eradicate fuel poverty. And the other one is part of the Offside organisation, which is the Wigan Youth Zone, which is a fantastic charity and a fantastic organisation where they've got a number of these centres for younger people, let's say, around the country, and they need everybody's sort of help and support to keep these things running. It really sort of makes a difference to a lot of children's lives. Next slide, please, Chris. So what does Energy Ace do? Well, we basically manufacture energy saving solutions. We're power quality engineers. So if you've got an issue with power, not quite sure what it is, we're the sort of go-to guys. We don't only sort of measure and investigate the issue that you've got. Most of the time, we'll actually manufacture that solution for you. We have some pretty bizarre solutions that we manufactured in the past, but I guess 2 of the main ones we're going to talk about today is voltage optimization or voltage management. Which sometimes it can be a sort of controversial technology, and power factor correction, which in all honesty again can be quite controversial, but it is really all about where these technologies are applied really and how they're applied. And the only controversy I think in the past has been where it's been sort of applied in the wrong places really, but the internet is a wonderful thing, and there is 1 or 2 horror stories, but when applied right, they're definitely the right sort of solutions. We're also heavily involved in energy metering and in sort of large distribution and switchboards for the supply of electricity. Next slide, please, Chris. So we're a big believer on strategy. So, a lot of organizations will think, okay, so I want to save money. I want to reduce my carbon footprint. I want to save the planet. But how do I do this? Where do I go to first? There's a lot of different solutions that are out there. Some of the very much the right solutions for the right application. But as I mentioned before, with a couple of technologies that I'm going to deal with today, in the wrong sort of, if they're applied in the wrong way, then perhaps a much lesser impact from that solution. But then, of course, if you're using energy, where are you using it and how are you using it? It's a much better, you can get a much better outcome when you understand power and where it's being used than if you didn't. So, the first thing we look to do is to get data from a client, and if they've not got that data, we look to get it ourselves by introducing either temporary metering on or permanent metering, or remote metering and monitoring. So to give some good visibility to how your energy is being spent. Once you've got that, like I say, forearmed, it's forewarned. We can sort of look at the right solutions. Next slide, please, Chris. So 2 of those solutions, like I say, is voltage management. Next slide, please, Chris. So voltage management or voltage optimization has been around over 100 years. It was first used in glass furnaces to adjust the power of a glass furnace. But in all honesty, the cost of energy has risen disproportionately to the cost of manufacture of these type of solutions. So all of a sudden, it's now viable as an energy saving solution. And in fact, all it is a control valve on the supply that comes into your site, whether it be an office, whether it be a home, whether it be a retail organization or a big industrial site. If you can get a little bit more control, if you control something, you can normally save some energy from that level of control. And if you think about the voltage in the UK, what we're receiving now, it was historically, it was 240 volt. My house is 249. I'm in an industrial facility here. The voltage is 243, which is obviously the single phase equivalent of say 400 or 415 volts. But back in, quite a few years ago now, there was different voltages all across Europe. So some parts of Europe, the voltage was 220, some were 230, and like us, we were 240. But when you're designing an electrical appliance or a machine, the different voltages can sometimes offer a different power output. So it was crazy when we've got all one sort of common market, let's say, and one market where, you manufacture something in Germany, you don't just sell it to Germany, you'll sell it throughout Europe and in some cases throughout the world. And the same thing with the UK, we manufacture something here, but equally it might be installed in Spain or Scandinavia or whatever. So really we needed a common methodology or what you call a harmonization of voltage. So basically for around about I think about 10 years now at least, we've been looking at a voltage where everything is designed at the same level. So that is 230 volt. But in reality, nothing has changed. Our nominal voltage or our voltage that we still operate at, let's say, is 240 and the average is 242. And when you compare that to the voltage level in mainland Europe, and the highest is 243, our average is only 1 volt below. Yet we can go all the way up to 253 and commonly do. Next slide, please, Chris. So if you think of voltage as a pressure, and if that pressure is being applied to an appliance, let's say higher than need be to do exactly the same job, then that appliance is going to deteriorate quicker and it might consume more energy as well, without really giving you any difference in output. A typical application for that is, or example should I say, is LED lighting. So any LED that driver, that little transformer, that LED, if that's receiving a much higher voltage than it needs to do, then it will deteriorate more quickly than it should do. And we've got lots of examples with petrol stations where the canopy lamps are failing much quicker. A lot of industrial applications which is exactly the same. So, if the voltage is much higher than it needs to be, then there's a lot more deterioration. Next slide, please, Chris. But equally, it might actually be consuming more energy as well. So the main sort of benefits of power factor of voltage management or voltage optimization is a reduction in kilowatt hours, because we've managed that voltage, we've managed that pressure to your machine or your appliance or your lighting or whatever that is, and it's now working more efficiently. You will get a reduction in maintenance costs because appliances are operating or lasting as long as they should do. And a good example of that is let's say many years ago, your TV, for example, might fail, and you used to take it to Rumbelows and get it fixed, and 99 times out of 100, it was a little transformer in the back. Now you wouldn't do that. You'd probably go out there and get a new TV. But in reality, what's probably made that fail is that higher voltage, and it's only a little transformer in the back. So the good applications for voltage management are those with really long opening hours. So the biggest successes that we've had is like restaurants, pubs, fitness centres, retail organisations with long opening hours, factories that could be either plastics or machine shops or anything like that that tend to have long opening hours. They tend to be the best sort of fits. Next slide, please, Chris. So if we move on to another technology now, and both these technologies in a lot of cases are quite complementary. So we're with voltage management, we're acting like a control valve as such to, to manage that power that's coming in. Power factor correction works in a completely different way. And basically what we're doing is we're looking at what you call inductive loads, which are basically motors. So any machines or motors, they're all inefficient in one way or another. Even if they've got what you call a variable speed drive or whatever, it's still a motor at the end of the day, and it's still what you call inductive. So if we can introduce an equal but opposite effect, let's say to the inefficiency of a motor, then you normally get a cancellation of energy, a cancellation of power. So if you think of a motor being inductive and you think of power factor correction being capacitive, well, inductive and capacitive are two opposites. So basically what power factor correction is introducing capacitors onto an electrical system to basically cancel some of the energy that's already there. And if you look at the sort of example that probably you'll see all over the internet as a pint of beer, let's say, or equally it could be some fizzy pop or whatever, then basically everything in that glass you are normally paying for as a consumer of electricity. Yet the real power, the power that actually does the task, might not be filling that glass. The head, let's say, at the top of that glass is basically the reactive power. It's the additional power drawn, but doesn't really contribute. So all we're doing is we're basically ensuring that everything in that glass, you'll be able to use, it will be useful. So we're removing that reactive power, basically. Next slide, please, Chris. So if you concentrate on the sort of center numbers there where the example is, this is a typical industrial, let's say, load. And this is something we get very, very often. So a typical industrial load, if you think of power factor being a level of efficiency, let's say, it's operating at 0.8 power factor or 80% efficient. That would create what we call a KVA, which most supplies are rated on, of 1,250 and around about 1,700 amps, let's say. That exact same load, just by adding power factor correction and not changing anything else, as you can see, has reduced the KVA by about 240 and the current by 334 amps. Now that implication is, first of all, power that is supplied to you. You normally pay what you call an availability or a capacity charge, which are for the larger supplies, and they're roughly about £1 per kVA, and in some cases double that. So you can normally get a saving of around about £240 a month, or I'd say even double that. But equally, if there's much less current flowing through your electrical system, then there's much less what you call losses. So basically, every time a current flows through a cable, you basically get a heating effect. That heating effect is like plugging in an electric fire, let's say. If you're plugging in an electric fire, you consume energy. Those are the losses. So we're reducing the losses, basically. And as you can see, there's massive reductions in demand. So if your organization, let's say, is potentially overloaded and the main supply keeps tripping, then this is a really good application to stop that from happening. Or equally, if you want to expand and you've not really got enough power, again, it's a really good application, a good solution to look at is power factor correction. Next slide, please, Chris. So the benefits, a lot of the benefits are in kilowatt hour losses, as I've just described, but also large commercial and some industrial premises will have a penalty called a reactive power charge or reactive surcharge because the power factor is low. And that's really because the network operator, the DNO, and I know you spoke to Electricity Northwest before, they have to put in a bigger infrastructure for you if you're pulling more energy than you should be to do exactly the same task. So someone's got to pay for that, and there's normally a penalty, like I say, it's a reactive power charge because that organization is pulling more power than it should do. And then the great sort of applications for this is industrial and process intensive, which basically means anywhere where there's a motor, but it doesn't have to be just industrial. I mean, basically we work with a lot of the big department stores. They've got some of the big department stores are like a little village, the amount of energy they consume. In fact, if not a town sometimes, so really, if you think about any application where there's a motor and quite a lot of motors together, or machines. And that could be a compressor, can be a fan, can be escalator, can be air conditioning, lots of different sort of applications for motors. Then power factor correction would normally work in that scenario. We've had a lot of success in food and chemical, refrigeration. So yeah, so there's, again, motors, to be fair. Next slide, please, Chris. And then you think, well, why isn't everybody doing this? And to be honest, a lot of people are doing it. Going back many years ago, and again, power factor correction has been around a long time. This was done with almost every installation, every electrical installation. If it's three-phase and they've got motors, would have power factor correction. But I think the cash restraints going forward with different different projects or whatever. Some engineers these days or designers these days tend to look at it and see, what they can maybe knock out of that final sort of delivery. Then it's left to the customer who's actually operating that site to look to save energy. So it has been around a long time, and the biggest barrier really to I think bringing solutions in like this sometimes is cash. And as you can see from that slide there, 60% of professionals say that's the biggest barrier is trying to fund it. But, we have funding solutions. There's a lot of grants available out there as well, and typical return on investment for both of the technologies that I've spoken about today is 1 to 3 years. So if you think about, if you're saving sort of 5, 6, 10, 20, 30 grand a year or whatever, that's a lot to save when you've actually paid for the solution in 1 to 3 years. So the return's really very good when you compare it to some of the other technologies that are out there. And the proof of the pudding really is to sort of engage with us. Next slide, please, Chris. Is really to engage with us, and we'll have a look at the data that you've got. That could just be simply an electricity bill, or we might say we need a little bit more data, and we'll do some monitoring and find out if we can help you or not. One thing for the future and the innovation that we're doing at the moment is carbon reporting. And this is only something that's going to grow in the future. And if you think about all the different scenarios now of power that can supply even your home really, but it's certainly your retail site or an office or an industrial site. Nowadays we've not just got the grid. We've got wind turbines, we've got solar PV, we've got combined heat and power, air source heat pumps, lots of different sources of energy. So to try and work out the carbon footprint from all these different types of energy is sometimes really difficult. And sometimes for a business owner, it might be something that, you'd rather someone else do, while you get on with doing something that you do very, very well. So we've designed a tool that basically will monitor all the different elements of generation and create an overall carbon footprint for you. Now that's due to be released in the next 2 months. We're very much on with it. We're in testing at the moment, and that's a little spot of innovation to sort of keep your eye on. Next slide, Chris. So yeah, as it says, if this is something that you're interested in, reducing your carbon footprint, reducing your energy spend, being a bit more conscious, then by all means get in touch with us. My contact details are there. You can look on the internet for EnergyAce, energyace.co.uk. We're in Buckshaw, around Leyland, and we're happy to help you going forward. Thank you very much, and thanks, Chris.
Thank you very much, Gary. We've got a question. I think it ties into the previous presentation on businesses and EVs and charges and capacities. It's from Eugene. It just says, should have asked the previous speaker, but businesses may soon be charged penalties by the DNO for hogging spare capacity. So power factor correction and VO could have additional financial benefits by allowing businesses to release capacity. Careful not to release too much capacity, as may not get it back from the DNO. Do you have any thoughts or expansion on that?
No, that's true. That's true. I mean, there's a place up in Cole not long ago. It was an industrial site. They outsource a lot of their manufacturing, to I think it was the Far East, but yet they still had the same building. They ran it more as an office, not as a manufacturing facility anymore. Their capacity had dropped from 1,000 kVA to around about 30 kVA. Yet they were still paying for 1,000. Just doesn't make sense. And to be fair, no one's going to come knocking on your door normally from the from the guys who organise the capacity to say that you don't need this.
No, that's very true. There's I said with I can't remember the actual term, but there's some changes coming in now. Basically, they're going to be measuring and monitoring and setting the capacities and whatnot. That's coming through. So people should check with their energy DNOs and energy suppliers to see what ratings they're at. And it's going to be a tricky thing for you to sort of be flipping between if you're allowed at all, really. So it's kind of getting it right from the outset in the next 12 or 18 months, I believe.
If I can just add to that, Chris, it's going to be a more banded system where at the moment you probably pay per pound per kVA to a degree anyway.
Yeah.
It's going to be a more banded sort of approach. So if you can drop a band, let's say, in all honesty, I don't know how that would affect cost-wise at the moment. I'm not even sure if the sort of costs have been put together yet, but I think that's coming in the next year or so.
Yeah.
But yeah.
I was going to say, just while there's not any more questions as we stand, but we've still got a couple of minutes, so I'll just sort of fill a bit of space. Have you got any sort of examples? Obviously, I know they're not going to sort of come up on a slide, but any examples of some interesting jobs that you've done, where in interesting places, either here or an interesting problem that you've solved that maybe other people weren't able to, to see the wisdom in it, and you've got VO or power factor correction and got it working and got it saving the customer benefits and energy.
Can I share my screen, Chris? Is that possible? For a second?
Technically, no, because it's just set to mine as a host, and I've not been able to do it for our co-hosts without worrying about turning everything off. So unfortunately, I can't get you to.
That's okay. That's okay. So I can give you 3, let's say, case studies, and again, these are very available. If anyone wants to contact us, if they've got whatever sort of whatever space they're in, we've probably got a case study that we've worked with, and we can send them through. So a typical one is a hotel, so Q Hotels. So Q Hotels, we did a number of their sites. We used both power factor correction and voltage management. We saved them £162,000 a year. It was a 12.1% saving. We saved 873 tons of CO2 a year.
Wow.
Payback was 1.89 years. We improved the efficiency to 0.99, removed those reactive power charges, reduced the demand, and they had immediate cost savings. So that's one example. If I can give you another one, the restaurant group TRG, we did 227 restaurants, saving of just over £1 million a year now, 12.77% saving, just over 5,000 tons of CO2 and a payback in 2 years. And a very different organisation was a news agents. We're ongoing with this, so we're under an NDA, so I can't exactly say who they are, but let's say they're very well known. And again, we're saving, although they're only small news agents, we're saving on average about £2.5 grand a year. Payback is less than 2 years, 10.2% saving, and round about, what would it be, about 4 tons of CO2 a year.
Fantastic. So some fantastic numbers, those. We've had a question from Simon Rainish, and it's just if there's anything more specific. Obviously, you've been involved with us previously. It's just any information on grants that are currently available for businesses. Just wondering if, obviously, in the Lancashire low carbon area, we can help people support with their grant paperwork, but we don't have anything offer right at this moment. Do you know of anything else in terms of support for your technology or wider technologies?
In Lancashire, you've got the what's the other one for plants? Sorry, in Lancashire.
There's the Lancashire Environmental Fund. Again, some of these, just as a bit of a disclaimer for us, is we're aware and know of these, but they're not our schemes. As Chamber Low Carbon has previously run one, so we're not actually able to sort of say the absolute ins and outs. But there's the Lancashire Environmental Fund, which covers flora, fauna as well as technology. And
there's another one. It just doesn't spring to mind at the moment.
there's a national one as well, which is usually for bigger infrastructure, which I think is for sort of large cooling plant, heating plant, sort of filling your warehouse full of solar. There's a minimum spend, I think. I think it possibly is around about the 10k mark, called the Energy Renewables or Energy Renewal Scheme.
Yeah, if they want to, if Simon wants to just email me, or if he can supply you with the email and you pass it through to me, there are about four areas, to be honest, that I can sort of put through. They just don't spring to mind straight away. One other important factor, though, is at the moment the government are offering extra tax advantages as well on capital spend. So I think they're offering 130% against any capital spend, and that's for the next sort of 12 months, if I remember right.
Right.
Both these technologies comply with that.
Well, that's very good. So I just copying down so we make sure that we connect people that want and need to be connected. So thank you very much for that, Gary. Appreciate your penny for your thoughts on that, because obviously it's sort of, they're a bit of a merry-go-round, aren't they? And at the moment, it's sort of trying to make sure that we're all aware of the pots that are available to people. And obviously, just as a disclaimer, because hopefully we've got people from further and wider than Lancashire, as well as our sort of local family, that there will possibly be other grants, which is what Gary's just mentioned there. That'll be on a national level. But as Chamber Low Carbon, our immediate sphere of knowledge, usually in terms of grants, is it's the Lancashire area. We've also got Martin Baxter tomorrow from IEMA, who's one of the professional accreditation bodies, and he's involved a lot with policy and on the lobbying groups, and helps form government policy. So he might have some insights for those people that are tuning in tomorrow as well.
Great.
Gary, do you have your case studies online? Are they easily findable? I think that obviously for those that are listening, obviously we could maybe tweet out your case studies page, let people find a little bit more about you, and get to see all the applications so that you can put what technologies you've been discussing.
Yeah, if you go to the website, there's an area dedicated just to case studies. So there's lots of different types of industries and commercial sort of organisations on there to give a flavour of what we can achieve. So yeah, by all means have a look at that, and yeah, we can tweet everything out. We're on LinkedIn as well, so we can put something on there as well. So
yeah, fantastic. Yeah, we'll have a look to do that as we're sort of moving through the presentations. We've got our team behind us, but if you wanted to tag us in anything, then it's going to make it a nice smooth process for us all. But we're happy to like and share and show a bit of love.
Brilliant. Show a bit of love. That's what we want.
Fair enough. It's the weather for it, isn't it? I think. Have you got anything else to add? Is there any more, or should we wrap up and say thank you very much for your time and a very interesting, informative presentation on levels of the technology, and as I say, with the grants and in terms of subsidies and things from government, that's really helpful.
No, thank you, and thanks for everybody to spending the time in this very, very warm afternoon.
Yes, the blinds are shut, so I'm not crying. But hopefully we'll get to see you. We'll get to see you soon. It won't just be over audio. But thank you very much for coming.
Good. All right. Thank you.
Thank you. Bye now. Bye.